So in this video, let us finish with section C of 2024 GCE Science Paper 1. So we are answering section C. That is the last part where you get to choose 2 questions out of 3 questions that are given. So we are going to answer all the questions. And the questions there, or the statement there on top, the instructions that answer any 2 questions from this section in a separate answer booklet. Okay, so let us look at the first question, which is C1. So figure C1.1 shows the result of velocity and time recorded for an object that was dropped from a certain height on the surface of the moon. Now, as you can see from the table here, we have velocity, we have 0, velocity, we have 1.1, 3.2, 4.8, 6.4, and 8. Then, of course, time we have 0, 1, 2, 3, up to 5 seconds. Time is in seconds, velocity is in meter per second. The first question here of Roman numeral 1, question of A, that is on C1. Plot the velocity time graph against time. Plot the velocity time graph against time. So we are not going to waste time. We are going to go to the graph paper and, of course, do the plotting. But of course, take note of the numbers that we have. So for the first one, we have 0, 0. And of course, the end for velocity, we have 8. And of course, for time, we have 5 seconds. So now, before you plot a graph, these are the things that you need to know. Is that a graph should be at least 75% of the graph, or should cover 75% of the graph paper. Okay, should be large enough. So the scale that you use should be large enough to give you about 75%. Should not be small. Okay. Then of course on your graph you should have a scale. Then the other thing that you should have on the graph is that on a graph, aside from the scale and of course filling the 75%, you need to know that you use a pencil putting up a graph. Because some of you might use a pen to put up a graph. So you use a pencil. Everything on the graph, you use a pencil. And as you can see, the pencil that I'm using here is just that it's a red pencil so that you can see clearly. But in an exam, I'm sure you go with a black pencil. Okay. So also the graph should have a title. Okay. The title normally you extract from the question. Like for this one, plot a graph of velocity in meter per second against time in second. So just cut it here. You just cut it here. So the title is graph of velocity in meter per second against time. That is your title. And of course should be on top of the graph. So having said so, let us go to the graph and plot. Okay, so here is a graph paper. And of course I'm using the Zambian standard graph paper. So now what are we going to do? We are going to come up with a scale. We are going to come up, with a scale. So please, the other thing that I forgot, for you to have an accurate graph, at least leave a line of boxes on one end. Okay. So which means, and of course on top, leave at least a line there or 2. So I'm going to leave just 1. So which means my y-axis will start from there. Okay. All the way coming down. I'm drawing my y-axis all the way coming down. Let me put up to here. Okay. Then of course my x-axis, or let me extend it up to here. Then of course my x-axis will go this way. I can go up to there. Let me see if it will give us. So this is, you can even indicate this is the x-axis. And of course this is the what? The y-axis. So I've put the x and y-axis, and this is 0. Now, the remaining part is me to choose the scale. Which scale am I going to use on the x-axis? Now, to choose the scale on the x-axis, and we are told plot the graph of velocity against time. So time is going to be on the x-axis. And of course, you've seen time, it goes up to 5. So I need 6 boxes because I have 0. Okay, not 0, not 6, but 5. So I'm going to use 2 centimeter. You know that each of these boxes is 2 centimeter. So I'll put a 1 here I'll put a 2 here, 3 here, 4 here, 5 there. So I'm moving in ones per 2 centimeter. I can put my scale here that 2 centimeter is representing 1 second in terms of time. So that is my scale. Okay. Then what about on the y-axis? So on the y-axis, if I see my highest number is 8. Okay. So I can choose to put even a 2 centimeter. Okay. 2 centimeter to represent 2 meter per second. But if I put 1, is it going to sustain me? Let's say 1, 2, 3, 4, 5, 6, 7, 8. Okay, happen that 1 is going to sustain me. Now, what is the scale that I'm going to go with here? So 2 centimeter equal to 1 meter per second. But of course, you can choose any other scale, it will still accept. So now, having chosen a scale, if I choose a 1 for 2 centimeter, here in between, you need to know that there are 10 boxes. These small boxes here, there are 10. Now, what is the size of each small box? You need to know that because some of the points are not exact. You have to count. So if I use a 1, I use a 2 centimeter for a 1, I need to divide 1 divide 10 to know the size of a small box, and it happened that it's a 0.1. So each small box on both axes is a 0.1. Now you're going to see the importance of this as we start putting up the numbers. So the first point here that we are putting is a 0.0. Okay, and before this, maybe let me just put up a title. So on top here I can put graph of velocity in what? Meter per second against time in second, or time in second. It's just bracket then S. Now the other thing that I forgot to put that this side is velocity of course in meter per second. I hope you are able to see the color. Then this side I'll put time. Okay, time in seconds. That is what I forgot to label. So the first point we said is a 0.0, so it is right here. Then of course, maybe let me try to change the color. Let me put blue. So the first one is 0.0. Then the second point is on the x-axis is 1, then y is 1.6. So I'm going to stand at 1 and of course follow it up until I reach 1.6. Now 1.6 is above 1, and we said each of these is a 0.1. So if this is 1, this is 1.1, this is 1.2, this is 1.3, 1.4, 1.5, 1.6. So 1.6 is somewhere there. So from 1 and 1.6, they are going to meet right here. So we start by putting up the dots first. Then of course at the end you connect it. Then of course I'll go for 2.3. Okay, 2 and 3.2. So 2 is right here on the x-axis. Then 3.1, 3.2. So it will be right there. Then the next point, it is 3.4.8. So 3.4.8. This is 3.4.8. This is 4, 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8 is right there. Okay. Then the other point that I'm targeting is 4.6.4. Okay, 4.6.4. So 4 is right here. Then you follow it up. 6.4. 6.4 is 6.1, 6.2, 6.3, 6.4. So 6.4 is right there. Then the next point is 5.8. Finally, 5.8. So 5 is right here and follow it up to where 8 is, and 8 is right here. So these are the points that I'm going to join now. So starting from there, or I can start from the top here, join them with a smooth, okay, I've missed the point. Join them with a smooth, wow, with a smooth line. So I'm joining them. So in the case you have the meter rule, you use the meter rule. Okay, so at least I've tried. So it comes out like this. Okay, so it comes out like this. Okay, then now what are the questions that are there? So this is the plotting that I've done, and of course just plotting, that is 4 marks. So what do you need for you to get 4 marks? You need to have a title, you need to have the scale, need to be there, you need to have the smooth, this curve, so the curve that you produce, the accuracy of the curves gives you some marks. So this is how you earn some marks. So make sure that you include all these parts, and I'm sure the graph or my graph is clear. Then now let us go on and answer some questions that remains. So the plotting for this part we are done. Use the graph to determine the time when the velocity was 4 seconds. This is easy. So at 4 seconds, you bring it here. Then of course you pick time from down here. I guess you are able to see, so you put these dotted lines. So for me, time here is that is 1.1, 1.2, 1.3, 1.4, 1.1, 1.2, 1.3, 1.4, 1.5. 2.5 I mean. So time here, so I'm going to put here Roman numeral 2. Roman numeral 2 is 2. What did I put? 2.5. 1, 2, 3, 4, 5. So 2.5 seconds. So time when velocity is 4 meter per second is 2.5 seconds. Calculate the gradient of a graph. So to calculate the gradient of a graph, you pick any of the points. I can pick 0,0 and one of the points. So I can pick from here. I can pick this 0,0, and of course even this one, or any of the points here, 2 of the points in short. That is the one that you pick, and you calculate gradient. So we are answering Roman numeral 3. So gradient is equals to y2 minus y1 divide x2 minus x1. So what is our y2 here? Since we said we are going to pick 0,0, and let me pick 1, I mean 1,1.6. Okay, as the points. So this one carries x1, y1, x2, y2. So my y2 is 1.6 divide, or 1.6 minus a 0. Then divide 1 minus a 0. Then here we are going to have 1.6 divide 1, which is just 1.6. So whichever points that you are going to give is still give you 1.6, because this is a straight line. Okay, so that is how you work out the gradient. So you pick any of the 2 points along the line. Then what does the gradient on the graph represent? What does it represent? So that is what was this question? So that is Roman numeral 4. So indicate the questions. Roman numeral 4. So it represent acceleration. That is a velocity time graph, so it represents acceleration. Okay, the final question, state the principle of conservation of energy. What does the principle of conservation of energy state? What does it state? So everything or every information is on the graph. So that is where I've put the information. So this is a B. So energy conservation state that energy can neither be created nor destroyed, but only converted from one form to another. That is what the principle, that is what the principle of energy conservation state. So this brings us to the end of this question. That is question 1. So we've answered the question fully. Okay, so this is how the graph looks like. Just a recap, this is how the graph looks like. Okay, and all the questions, we've answered them. Okay, so for C2, figure C2.1 shows a waveform indicating the voltage produced by a generator. What type of electricity is produced by the generator? So the type of electricity produced by the generator is called the AC, or in other words, it's called alternating, or let me say in a complete form, it's called the alternating current, otherwise known as AC. Okay, then now, determine the maximum voltage produced by the generator. So this one is determined from the wave that you are able to see here. So the maximum voltage, you look at the amplitude of this wave, and it happened to be 5 volts. So that is the maximum. Okay, 5 volts. Then of course, state 2 ways in which electromagnetic force EMF produced by the generator can be increased. What are the 2 ways? So one of them is increasing the speed of the rotating coil or magnet, increasing the speed, so increasing the speed of the rotating coil or magnet. Also, we can look at using or use the stronger magnet. So the strong magnet produces or it increases the electromotive force produced. Okay, so these are some of them. So please, if you have some of the way we can include or we can increase the electromotive force produced by the generator, be able to suggest them in the comment section. Okay, and we've forgotten one question, that is to define a transformer. We are going back to this one. So now, the number of coil here, the number of turns on the coil, they are less compared to the secondary. So the secondary, you find that there are a lot of turns here. That is how you draw a step-up transformer. Okay, that is how you draw a step-up transformer. But of course, we forgot to mention, to define what a transformer is. Now, the question that is here is that what is a transformer? That is the first question that we forgot to answer. So it is the device, a device that step up or step down the voltage. So in other way, we can say it's a device that varies voltage of the AC supply. So it either step up or step down. So 2 types of transformer. It can be a step up or a step down. A step up transformer, number of coils here are less compared to here. Explain why. So we are on to question E. Explain why it is cheaper to transmit electrical power at a high voltage. So it is cheaper because it reduces the power loss. Okay, it reduces the power loss. It reduces the power loss, and of course power can be lost through heat. Okay, so it reduces power loss through heat. That is why it is easy to transmit power at high voltage. What does it mean to laminate the iron core of a transformer? What does it mean to laminate the iron core of a transformer? This simply means coating iron core with an insulator. So it means coating iron core with an insulator. That is what it means. Okay. So we've answered this question fully. And of course, please, what I'm emphasizing here on the part for drawing a transformer, either a step up or a step down, look at the marks, 3 marks. So you should take this one seriously and of course know how the step up or the step down transformer looks and all that. Up to the last question. So if you are choosing the 2 questions that we've answered, then you leave out this one. But of course, if you chose one or you had answered one, you need to also answer this one. So the first question is define nuclear fusion. Define nuclear fusion. So we have nuclear fission and nuclear fusion. So when you hear of fusion, just think of joining. So this is just a joining of small nuclei to form a large one. And of course, in the process, energies are produced. So in writing, we can say this is the fusion of light nuclei to form heavy nuclei, producing large or huge amount of energy, in the process. So that is nuclear fusion. So this is simply the fusion of large nuclei to form heavy nuclei, or small nuclei, I mean light nuclei. The joining or the fusion of light nuclei to form heavy nuclei, producing large amount of energy in the process. Okay. Then of course the second question here is state 2 similarities between nuclear fusion and nuclear fission. What are the 2 similarities? So 1, both processes produce or release huge amount of energy. So they both release huge amount of energy. And of course, lastly, we can say the reactant of both processes are unstable radioactive nuclei or elements. The reactant of both processes are unstable radioactive elements. Okay. In nuclear fusion, mostly used is hydrogen, which form helium. In nuclear fission, uranium break into barium and krypton. Then of course, up to the third question, that is of A, write an equation for the reaction of hydrogen, and that is hydrogen 2 and hydrogen 3 to produce helium. So we have hydrogen 2 plus hydrogen 3. What is going to produce 4? That is helium, and of course plus energy is produced. That is what we said. So this is the fusion equation. Name a device that can be used to measure radioactive radiation. What are the devices that can be used to measure radioactive radiation? So 1, you have what we call the spark counter. Then we have what we call the, I don't know how to pronounce this one, the Geiger-Müller counter, or GMM C. Okay, so quite a number of them that you can look at. So get to look at some more and look at how these works. Okay, and which one is suitable for gamma, alpha, and all that. I think you need to go into detail. Then 2, which radioactive emission is not diffracted by electric field? So here, the one that is not diffracted is gamma radiation. And this is because it has no charge. Okay. Then of course, question C, a radioactive sample of mass 200 has a half-life of 8 days. How much of the sample would have decayed after 32 days? So now here, we are looking for the sample that decayed. Now, what we are given here, we are given the initial amount, the half-life, and the time that elapsed. So there are different methods that you can look at. If you want, you can draw a table where you look at the half-life, for example, the 200, the half-life. Okay, now, for that one, you go, so for the half-life is 8. So divide 2 here, so half-life 8. In the first one first, 0, then half-life 8, half-life 16, half-life, you continue adding 8, 24, half-life 32. Then you look at the mass, what mass will remain. So 0, here the mass that will remain is what? 100. The mass that will remain is what? 50. The mass that remains is what? 25. The mass that remains is what? 12. That is 12.5, should be 12.5. So after 32, the half-life, the mass that remains is the 12.5. Okay, you can go with this one, but I like calculating. So you use number of sample that remains, divide the initial equals to half n, where n is equals to time elapsed, divide divide half-life. Time that elapsed is 32, divide half-life is 8. This gives you a 4. So n, we are going to put a 4. We are looking for the one that remains. Only if you find that remains, we can subtract from the total or the initial, then we have found what decayed. So now the target should be to find what remains. So the initial was 200 equal to half n we found to be 4. Now indices we apply. This is just the same as 1 over 4, 1 to the power 4 divide 4 to the power 2 to the power 4, which is just 1 over 16. So what we have is n over 200 is equals to 1 over 16. We cross multiply, we are going to have 16, n equals to 200. 16. N, I'm sure you should be able to find 12.5 when you divide here. Okay, then of course we have state 1 way of handling radioactive substances. State 1 way of handling radioactive material. So how do you handle them? So in handling this, radioactive material should be stored in containers lined with lead and of course buried underground. And of course when handling these, you use tongs to handle the radioactive materials. Wear protective clothing, and of course do not dilate the radioactive material toward humans. Okay, I think those are some of the safe precaution measures that should be taken when handling these substances. Otherwise we come to the end of the lesson. And of course, please, if you are interested to join us for online division, you can contact the number +26 0976 402563. And of course, it's 100 kwacha per subject if you are in Zambia. But of course, there are those that might be interested. They are not from the outside Zambia, but you are doing GCE Cambridge. You can also please WhatsApp the number if you have the past papers that you want answered. I can make the videos, but only if you help me with the papers that you have Okay, so you can WhatsApp the papers to this number, then we'll get to communicate. Otherwise, see you in the next one.